Hey class, today is going to be 13-2 and we're going to be looking at quadratic inequalities. And so today we're going to be solving these quadratic inequalities. So here's an example of a quadratic inequality, and the idea is we're going to be able to solve this inequality. And we're going to use this new thing called sign charts to be able to do that. Now if you remember yesterday, kind of the thing that we concluded is we always want to compare it to 0, because when we're comparing it to 0, we're separating the negative numbers from the positive numbers. And so that's why being able to separate that, it's going to enable us to be able to use these sign charts. So I want to rewrite this inequality to where f of x is on one side and 0 is on the other. So that means I'm going to have to add x to both sides, and I'm going to minus 3 on both sides. So I'm going to get 2x squared plus x minus 3 is less than or equal to 0. Then I can factor this, and so this is going to factor into, we know this is going to be 2x, this is going to be x, and it looks like it's going to be plus 3 and then a minus 1. And that's still less than or equal to 0. And so solving for this, we know that each of these, if I set them equal to 0 and solve, I'm going to get x equals 1 and x equals negative 3 halves. So I just need those zeros. Now that I have those zeros, I can put them on a number line. So I have negative 3 halves here, and I have positive 1 here. Because this is equal to, I know it could also equal the value, so that's why I'm going to represent this with a closed circle. Now I want to evaluate or test values that's going to be kind of like in between each of these intervals. And so I can do like f of negative 10. And all that's saying is I'm picking up, this is a number line, right? This is like negative 4, negative 5, negative 6, etc. I'm picking the point negative 10. Now, when I plug that value in, the only thing I care about is if my value is positive or negative. Because I know this has separated it into positive, negative numbers, I just want to know if it's positive or negative, and you'll see why very shortly. So let's plug it in, and I'll plug it into my factored form. And so plugging this in, I'm going to get a negative, because that's going to be negative 20 plus, so that's negative 17, and then this is going to be negative 11, which is going to be a positive number. So that means I'm going to write here that this is positive. Now if I pick a value in between negative 3 halves and 1, like 0, if I plug in 0, that's going to give me 2 times 0 plus 3 and 0 minus 1. So this is going to give me 3 times negative 1, which is negative 3. So that's a negative number. So I'm going to say that this region is going to be negative. And then the last one is going to be, it's picking a value on this side, so like, I don't know, 2. So then I get f of 2. And so plugging in 2, you're going to get a positive times a positive, so my number is going to be positive. And so this region here is going to be positive. Now this is the reason why I just want to know if my values are going to be positive or negative. And it's going to be this statement here. We're comparing it to 0, and this statement says less than or equal to 0. So I need to think, what numbers are less than 0? Are they positive numbers or are they negative numbers? In this case, it's negative numbers. So because negative numbers are less than 0, the negative regions represent my solution. And so then I can say that my interval is going to be negative 3 halves and positive 1, and that's going to be my answer. So the first thing that I did here is I rewrote the inequality to where f of x is on one side and 0 is on the other. So I rewrote this to where f of x is on one side and 0 is on the other. Then step 2 is I found the zeros of f and I placed them on the number line. So I found the zeros on f. So here's the zeros, -3/2 and +1, and I placed them on the number line. So I placed them on -3/2 and +1. Then I chose a real number and I test the value in each interval and determine if it represents a positive or negative value. So I tested a number here, -10. It represented a positive number. I tested a value here, 0. It represents a negative number. I tested a positive value here, 4 or 2, and that represents a positive number. And then choose the intervals that correctly correspond to the inequality. So this says numbers that are less than or equal to 0. So the numbers that were less than or equal to 0 are going to be these numbers here. And so that's why my solution is going to be -3/2 and 1. Example number 2. It says solve the following inequality using sign charts. So for this one, I need to rewrite the inequality to where f of x is on one side and 0 is on the other. So that means I'm going to subtract 1 on both sides. And so I'm going to get x squared minus 2x minus 1 is going to be greater than or equal to 0. Now this value doesn't factor. Let's see if it does. Because this is 1 has to be negative. Yeah, it doesn't factor. So because it doesn't factor, what we're going to have to do is we're going to have to use the quadratic formula. So negative b. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I'm going to get 2 plus or minus, and this is going to be the square root of 4, and then plus 4 all over 2. So this will be 2 plus or minus the square root of 8 over 2, which is 2 plus or minus 2 root 2 over 2. Now everything gets divided by 2, so I get 1 plus or minus root 2. Now that value there, we're going to enter into our calculator. And so entering in our calculator, we're going to get the values 1 plus root 2, which is going to be approximately 2.4, and so let's say 2.41, and then 1 minus root 2, we're going to get negative 0.414. So those are my zeros. So now, placing them on a number line, I have negative 0.414, and then positive 2.41. Now because it says there's no equal to symbol, each of these are going to represent open circles. Now step 3, I need to choose a real number in each interval, and I'm going to determine if it represents a positive or negative value. So that means I'm going to need to take values from each of these regions, and I need to plug them in. So like a value here, I could say -1. So that means I want to plug in -1 into my function. -1 squared minus 2 times -1 minus 1. I just want to see if that's positive or negative. So I get 1 plus 2 minus 1. So that's going to be a positive. So I can say this region is going to be positive. Now let's try a value between here, like 0. So f of 0. So I get 0 squared minus 2 times 0 minus 1. And so 0 and 0, that gives me -1. So we're going to say that this is going to be negative. And then picking a value, let's say 3. So f of 3, that's going to be 3 squared minus 2 times 3 minus 1. 9 minus 6 minus 1, that's going to be positive. So now that I have my regions, I need to choose the interval that corresponds correctly to the inequality. Well, this statement here says greater than 0. Numbers that are greater than 0 are positive numbers. So my solution is going to be the positive regions. So that's here, and that's there. So my solution is going to be -infinity all the way to 1 minus root 2 union from 1 plus root 2 all the way to positive infinity. And I just use the exact values. And that's going to be my answer. Let's try another one. So I get x squared plus 6x is less than 8. Don't have to worry about that. So rewriting the inequality to where f of x is on one side. So I'm going to add 8 to both sides. So I'm going to get x squared plus 6x plus 8 is less than 0. Find the zeros, so that means I should be able to factor this. So this is going to be x plus 4, x plus 2. So that means finding my zeros, x is going to equal negative 4, and x is going to equal negative 2. Now, place them on the number line. So I get negative 4 here, I get negative 2. Because there's no equal to here, they're both going to represent open circles. So now step 3, choosing a real number in each interval and determining if it represents a positive or negative value. So choosing a number like in this region, like negative 5. So if I plug in negative 5, I'm going to get a negative and a negative, which is a positive. And so this region represents with a positive. Choosing a value in between, like negative 3, I can do negative 3 plus 4, negative 3 plus 2. So that's going to be a positive and a negative, and so this is going to give me a negative. And then choosing a value over here like 0, and so I'm going to get 0 plus 4 and 0 plus 2. So I'm going to get a positive and a positive, which is going to be a positive. And so it wants numbers that are less than 0. And so for step 4, choosing an interval that corresponds correctly to the inequality, it's going to be every value here in between. And so that's going to be my answer. And so the answer is going to be negative 4, negative 2 as my answer. Now, a few more scenarios to examine. If I were to try and plot this, or trying to find the actual answer, notice by minus 5 on both sides, it gives me x squared is greater than or equal to negative 5. If I take the square root, I know I'm going to get imaginary values. So our conventional method of what we did here isn't going to work. So let's look at this visually. If I graph this, say if this is 5, I'm a parabola that looks like this. Now it's saying every single value greater than 0. Well, if you notice, every single value that I pick for x is going to be above 0. So that means that my solution is going to be negative infinity to positive infinity. Whereas for this one, once again, I'm still going to get those imaginary numbers, but notice if I were to graph that, here's that 5, it says every number that's less than 0. Well, there's no numbers that are less than 0. Everything's above it. So in this scenario, there would be no solution. To close today's lesson, what did we talk about today, or what did we learn today? Well, we talked about quadratic inequalities and how to find the solution to a quadratic inequality. So what is the difference between f of x is greater than 0 and f of x is less than 0? So what is it that we're kind of looking for in each of those, I guess, was what I'm kind of implying there. And then what are the different ways to find the zeros of a quadratic? This does conclude our lesson. If you have any other questions, please leave them in the comments.